Just to give a quick rundown on myself and the company, like most people, I came to data science by a circuitous path. I used to be a physicist. I was a string theorist and cosmologist for about 6 years after getting my PhD. I did 2 postdocs. That's kind of what brought me out to Vancouver. If anyone wants really boring reading, I can give you my bibliography later. After that, I moved to industry. I was an individual contributor at Plenty of Fish, the dating site, for about 4 years. And then the last 5 years or so, I've been running the data science and machine learning group at Unbounce. I'm going to assume not everyone has heard of Unbounce. We are the leading landing page builder. So what a landing page is basically a page that is separate from your home page, that is usually tied to a specific marketing campaign. So it might be like, hey, like for this thing, like sign up for our like AI and mastermind series, and you'd have a dedicated page to do that. They're usually for things like lead collection, buying things, newsletter stuff, that kind of thing. We're a team of about 180. We're growing because we just got 50 million in funding. We're principally in Vancouver. We've got an office in Berlin, but with COVID, we're also very remote friendly these days, at least throughout Canada. So I do encourage people to look at our careers page. We have a whole bunch of roles open now and in the new year. And at any given time where we host our own pages via AWS, we're roughly hosting about 500,000 to 750,000 pages. So like the sort of value prop in our bread and butter is it's tools for people in marketing who aren't developers to be able to quickly and easily make landing pages and then be able to drive as many conversions as possible from those landing pages with a lot of insights and things like that. So one of the problems that our group deals with is these pages get a lot of traffic and a lot of different traffic. And the sort of like standard paradigm, if you look at like companies like, let's say VWO, Optimizely, things like that, is you run an A/B test, you find the best page for generating either clicks, conversions, leads, or that kind of thing. When the A/B test is done, you say, oh, the B variant won, that's my new champion variant. And then maybe you just stick with that, or you keep running A/B tests over and over and things like that. But we kind of got to thinking, like, what about all the different traffic that's coming to your page? And so kind of a cartoon version for this is, imagine you're selling soda. So I'm actually originally from New York City. But now that I live on the West Coast, it's called different things. So in New York City, if you want a Coke, people ask, what kind of soda do you want? But in Washington State, if you say, oh, I want a Coke, they're going to say, oh, that's called a pop. So you can kind of get an idea that if you were running an A/B test on this and you had all this different traffic, like, I don't know, maybe 60% of the traffic is from New York, then you're going to probably select soda, but that's still not the best page for the people from Washington State. So what does that mean? Like, let's say here's the 2 pages that I made. They're phenomenal. These are reasons why I'm a data scientist and not a web designer. But just imagine you can have a call to action that says Sprite is the best soda, and the other one is Sprite is the best pop, and buy copious amounts of it now. So like, which one is going to be the best? What you really want, though, is a system that in real time can look at the visitors coming in and say, oh, this person's from New York, they want soda. And this person who's from Washington State, they want pop. And this is kind of a cartoon version of what we're looking at. Obviously, there's a lot more things than just New York and Washington State that we examine. So one of the ways you can approach this is via something called Contextual Bandits, which I'll build up to. So a multi-arm bandit is, the toy problem is, imagine you have a bunch of slot machines and someone gives you a stack of quarters and they say, okay, here's like $1,000 in quarters. I want you to play the strategy to make the best money, like the most money possible. So like, what would you do in that case? So the first thing you do is you'd start playing machines at random, right? Just put some quarters in, start pulling all those things until basically one pays off. When one pays off, you say, oh, well, this one seems to, with my current knowledge, be the most valuable slot machine. So I should put some more money in that one. But you also realize that like it's not perfect, right? Maybe you just got lucky that one time. Maybe the slot machine next to it pays off a little bit like less often, but when it does pay off, pays off 3 times as much. So basically then you don't want to put all of your money in the first one that pays off. You want to balance by still exploring all the other options. And this essentially is the problem that multi-armed bandits are doing. What they do is basically balance playing what is your current best strategy, which is called exploit, with still exploring other potential strategies out there, which is called explore. So all a multi-armed bandit is doing is figuring out what's the most efficient algorithm for balancing this explore exploit. And this is way too much to do in a 15-minute talk. This is an entire field of research. Just to give some examples of like ones that are out there. So the simplest one is epsilon greedy, which sounds complicated, but all it really is basically whatever your best current option is, you play that 1 minus epsilon of the time. So you pick an epsilon, like let's say 5%. So 95% of the time you play what you think is your current best option. And the rest of the time you choose all the other options randomly. And then you just keep updating as you go. Epsilon decreasing is basically that, but what you say is that as I get more and more data, like my information is probably a lot better, right? If I've played 5,000 polls on all the machines and I know which ones are paying off, then probably I have a pretty good sense of like what the chances of each one giving me money is. And so in that case, I just decrease epsilon either over time or number of trials and things like that. And then you can do fancier things, like Thompson sampling Bayesian bandits, where basically you have some kind of Bayesian model for this. You compute the Bayesian posterior for the reward from each lever, each pull, and then you Thompson sample for the best likely option. What we're going to use is actually something called Contextual Bandit. So imagine what you have is instead like of all the machines being different, you've got machines that are from like, in this case, like 3 are blue, 2 are red. But what you basically have is like, let's say the slot machines are made by 2 different companies. So they're not exactly the same, but they're made by 2 different companies. So you might guess that information from one slot machine from, let's say, company A tells me something about the other slot machines from company A and vice versa with company B. So that means I can build a model around that. And I can try to predict, instead of having to play all the slot machines independently and randomly, I can use that model to make more informed predictions. In this case, what we call the context for the contextual bandit is like the company that's manufacturing. But in general, the context can be any information we think may be important. It could be like slot machines that are on the colder side of the casino, like for whatever reason, the way they work, like tend to pay off more often or whatever it is. So the context can be like one thing, it can be a whole variety of things like that. So what you need for a contextual bandit is some kind of backing machine learning model that can learn and predict off the context and then update in real time or near real time. So it can be like something as simple as like linear regression that you're updating. It could be complicated Bayesian models. You can do deep learning if you want. But what you want to do is basically pick something that can sort of satisfy the constraints that you have. So in our case, the contextual bandit, the context of that bandit is all the attributes of the visitor. So I'm not allowed to say all the attributes we look at, but certainly things like location is one of them. We look at various properties of their system. Are they coming in on a mobile device or are they coming in on a desktop? Are they like, let's say an Apple user or are they on Chrome? We can look at all these sort of properties that we can scrape off their system, and we can use that to infer where the decision is made in real time. So we actually built this. This is a feature that's in general release right now. It goes by the name Smart Traffic. And we actually can see that people get like on average 30% higher conversion rates than they would like running, let's say, an A/B test or something like that. We can also basically show that like something like 99.9% of the pages that we looked at benefit from the system. So it's one of the rare cases that I've ever built a machine learning model where like it works for everyone. Like most of the time you have to talk about like, oh, it's 80% accurate or it doesn't work in this situation or things like that. In this case, it basically just works. The worst it ever does is break even, but for almost everyone, it actually improves things. And that's basically it. So I'll pause here and I'll open myself up to questions, and I'm happy to answer whatever.
Yeah. So someone has asked, what type of data do you use?
For the person that asked the question, are you asking what type of data for the traffic are we using, or what type of data for like determining that the lift is 30% are we using? I'm happy to answer both. I just don't know which one the person wants.
Yeah, let's invite them on screen. I haven't done this before, inviting an audience member on screen, but let's give it a whirl if that audience member feels comfortable coming up and asking that question in a little more detail. I've just invited you to screen. So
Hi.
Hi. So I'm asking about the traffic data that you are using for the attribute calculation.
Yep. So I can't say everything because it's a little proprietary, but essentially what we're looking at is things we can scrape from JavaScript.
Okay,
so
like is it a structured data or unstructured, and then you pull it out?
It's generally unstructured data that we then have to piece out. So it's things like coming from like a user agent string. So we do quite a bit of like structuring it, but we also do enrichment. So for example, from like an IP address, you might be able to infer geolocation or a lat long or things like that. So we do quite a bit of enrichment downstream to like figure that out. I should say we also looked at, so there's a whole variety of attributes you can look at. You can also, for example, look at things coming from the query string parameters. So at like, generally speaking, a landing page will have like UTM codes attached to it, which are like Google's way of tracking, like Google or Facebook, people can say, oh, this is coming from Facebook, it's this ad campaign, so on and so on. So we did quite a bit of exploration. We were building this out as to what are the most valuable attributes to include in terms of conversion lift, as well as like for every one we add on, like if you add on like 7 to 8 to 9, like what's the marginal gain for adding that like next best one on? And how does that compare to the performance of the system? And so like we kind of found what the sweet spot was, but we're always open to iteration on that.
Okay, thank you.
Sure. Yeah, thanks for coming up there, Deepti, and asking a question. We did have another question for you there, Thomas. Philip has asked, can you speak a little about your technology stack? What databases, programming languages, AWS products, etc.?
Yeah. So on the like machine learning side, so we're an AWS shop, like throughout the entire company. Generally speaking, most of our machine learning exploration and code is in Python. We do a little bit in R, but it's primarily in Python. For the bigger stuff, we do leverage AWS like SageMaker and all that kind of stuff. We also have a custom like ML model broker that we worked on the data engineering team with. In this particular case, a lot of the code is actually in JavaScript and TypeScript. The reason for that is that when we move from prototype stage to actual production, it has to, one, live on our page server, like which is extremely locked down for security reasons and obvious stuff like that, because we don't want to get exposed to injection attacks and all that kind of fun stuff. It also has to make the routing decision in sub 10 millisecond timescale. And so calling out to like another Python model takes a while. And so for some of it, it's like we coded it in line in JavaScript and we worked with the main engineers for that so that it could be basically fast enough to do the routing. Because you'll find in marketing and things like this, like anytime like a page takes too long to load, like that actually decreases your conversion rate by quite a lot. So you don't really want to impact page load time in any serious way.